I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life. So if this is your first or second or whatever pretty early time listening to our podcast, when we say Melissa's a chemist, she really is. She's a chemist, and she's getting her PhD right now, and she already has her master's.
Woo!
And I'm not in any way, but every episode, Melissa has a lesson, something she's trying to teach me, and I learn it from ground zero, from no knowledge at all, other than just like regular old high school or something.
And the podcast that you've been present for.
And the other one, the previous podcast. So I do retain knowledge over time. Is something that is unique about me. Just kidding. And I try to learn it along with you guys. So, Melissa, what are we going to learn about today?
Well, Jim, I'm glad you asked. As the time of sweets is upon us, Halloween is getting close.
Oh, yeah, that's true.
I was thinking a fun one would be, do you know what artificial sweeteners are?
Oh.
How do they work? Why are they sweet? Why are they 0 calories?
Yeah.
I guess a better word than artificial would be alternative sweeteners.
Yeah, are they magic? Is another question, perhaps?
Absolutely. Definitely. Yeah, we're going to talk about whether or not they're magic.
Because it does kind of seem like weird that they exist at all.
Well, that's what we're going to be talking about today. That they exist, how they exist, why they're sweet. The main points are why they're sweet, tasting to us, and then also why they're 0 calories.
Okay.
So I guess these would be the diet sweeteners or the low-calorie sweeteners that we're going to be focusing on.
Sweeteners that are not sugar and are not...
caloric.
Do not have calories. Okay.
Yes.
Got it.
So that's what we're going to be talking about today. Are you ready?
I'm very ready. This is interesting.
This is hearkening back to the days of trans fats and the dark side.
Oh, yes.
Of chemistry.
Okay. So this is harkening back to it. Are alternative sweeteners in that dark side?
Alternative sweeteners hold hands with the dark side. I'm not sure we can say for sure whether or not they're dark.
Sympathetic kind of deal.
Maybe they're Anakin in episode 3 before he kills all those babies.
Yeah. Oh, man.
Gosh, that scene's the worst.
It really, really, really is.
Okay, so, and just how can you? How could you? I hated that. I was done at that moment.
Yeah.
Do you remember when we talked about cis and trans fats?
Yes, I do.
We also talked about that there were sometimes left-handed and right-handed molecules.
Yes, in that medication, that birth control medication, right?
It wasn't birth control, it was morning sickness, but that's really close.
Oh, yes, it is. Yeah. It was morning sickness, and it makes sense. And it had adverse effects whenever it changed from the left or right or something like that. There was some bad stuff that went down.
Right. Basically, there's left-handed and right-handed molecules in chemistry. And to the untrained eye, they would look the same. For example, if you're looking at your left hand and your right hand, they look the same just looking at them. They're just mirror images of each other.
Yeah.
But they are actually different. You cannot put your left hand where your right hand goes and it function the same. If you chopped off your left hand and tried to put it in place of your right hand, it would be attached backwards.
Right.
That same concept is present in chemistry.
So in a two-dimensional way, it could look the same, but in a functional way, it might behave differently.
Right. Exactly.
Just like the hand. Okay.
So just like when you're looking at your hand and you see the back of both of your hands, you're like, yeah, these look the same. But then practically they function differently. That is the same thing that happens in chemistry with molecules.
Okay.
So, and that's known as chirality.
Whoa.
Big word.
Yeah.
We can just call it handedness, left-handedness, right-handedness to make things easier.
Man, this is so weird. That is just so weird already.
Can you tell me why you feel that way?
Well, I think it just like it has a good analogy. Our hands is a good analogy. And so if you think about like, if you personify molecules and make them sound like, hey, there's left-handed ones, there's right-handed ones, it seems to make sense for a second. But then you're like, but these are molecules. And this is like at this like atomic level of stuff going on. Why do they have hands? I mean, like they don't have hands. So I'm like, why does that happen? It's just kind of freaking me out a little bit.
Yeah. And I can show you, but basically they are mirror images. So then when you try to overlap them the same way you try to overlap your hand, they just don't line up. If you try to put your left hand on top of your right hand, to make them match up, you have to flip them over. But then the side that's showing is your palm. And that's not the same as the back of your left hand. And then suddenly you realize that your hands are different, even though you kind of thought they were the same this whole time.
Yeah. It's just kind of, I think because I didn't know about it, I was thinking that, oh yeah, you've got the same elements put together. So like H2O. I just assumed that like they would just kind of, it would just kind of go together the same way every time.
Right. Well, and I don't know if I can say most or many, but a lot of molecules, especially those very simple ones, do.
Okay.
It takes some special conditions. They don't matter a lot, but it has to have 4 things attached to it, 4 different things, and that way they're all different. That stuff doesn't really matter. So not every molecule has handedness, only specific molecules. That's a good thing that you said. I'm glad you said that because I hadn't thought to bring that up. But not all molecules have that. Jam just affirmed me into his coffee cup. He said, halfway into his beverage.
I was just thinking, my mouth is really close to something. It's close enough, right? It's just like a microphone.
Okay. So, well, that's good. I'm glad that you got stuck on that. I'm glad I got to experience your wonder because I don't typically get to feel that same experience. You know, most people are just learning about it in the classroom. They're worried about their exam. They don't, a lot of my students don't take time to wonder and be in awe. And I, learned it in the same environment. So that was kind of fun. That was kind of a fun thing that you're surprised by.
I think part of it too is that like, it's sort of like, do you remember whenever you were learning grammar for the first time?
No.
And you'd learn things that are like, okay, here's a rule. Like you always do grammar something like this. And they'll say that. Someone will say like, this such and such grammar rule is always like this. Except when it's not. Like, I mean, even if they maybe don't teach you that till like the next year in grade school or whatever, there are these exceptions like that come about. And I kind of feel like I'm having that kind of realization right now. It's like, yeah, molecules, fit together and they like join together and they make different substances and stuff like that. And it looks like this, except when it doesn't. And it's like, what the heck?
Well, I'm glad that you got to share that experience with me. That was fun. Well, so the left-handed and right-handed molecules, we did talk about how enthalidomide, that was the medicine we mentioned in the trans fat episode, that it had a left-handed and a right-handed, and the scientists did a good job and isolated the left and the right. But in the body, when women actually took this medicine, it switched back to be a mixture, which is, I would say, does not happen often. It takes a special kind of molecule to be able to do that. And one caused very terrible effects and the other was just fine. So we saw just that dark side of the different handedness of the molecules, but they also can be used for other things too. It's not just that if you have the wrong handedness, suddenly you're going to die.
Right. Okay.
So
it's not always life or death.
It's not always life or death. It's not always very dangerous. Sometimes it's as simple as, does this taste like lemon or orange? One-handedness tastes orangey and the other handedness tastes lemony. They are the same molecule.
So like that molecule that exists in lemon juice and orange juice kind of deal? Like, or some part of it?
So I don't think it's found I guess it would be in lemon juice and orange juice, but it's found in the peel, but also it's used artificially to flavor. So one-handedness, one of the hands is lemony and one of the hands is orangey.
Interesting.
And the fancy word for that, so chirality is the nature of having handedness. The two different hands are called enantiomers. So my hands are mirror images of each other. They're not the exact same. That's called chirality. One is one enantiomer, left hand enantiomer, right hand enantiomer. You don't need to know that, but it's a big jargony word.
Yeah. Enantiomer?
Enantiomer.
Enantiomer. It's weird because it's also starts with a vowel. So if you say an enantiomer, it's like. Yeah,
that is also when you say organic chemistry and inorganic chemistry. Oftentimes people say inorganic chemistry. I'm in organic chemistry.
I'm in organic. Oh, yeah. Yeah. So
confusing.
Yeah.
But the one we're going to hit on today is artificial sweeteners.
Okay.
So our bodies are designed, and we talked about this, to generally process one enantiomer or the other of naturally occurring products. In chemistry, they're referred to R and S. In biology, it's slightly different. They're known as, I believe, D and L. Mm-hmm. I'm not a biologist.
It's like they label different enantiomers, those letters?
Mm-hmm. Yes, there's a way to determine it. It doesn't really matter.
Okay. But they have just labels for them.
Mm-hmm,
okay.
They have labels for them, and our bodies are naturally going to be able to taste and digest one enantiomer.
Okay.
So we naturally can digest that one enantiomer.
Okay.
If you have the mirror image, the opposite enantiomer. Mm-hmm. I think in biology, the ones that naturally occurring that our body digests are typically the D enantiomer. If you have an L enantiomer of a sugar, you're going to be able to taste the sweetness, but they will pass through our body undigested because our enzymes only know how to digest the D enantiomer.
Okay, so say sugar is right-handed.
Yeah, we'll just arbitrarily assign it.
Okay. Because it's the more common thing that we're used to, even though there's a lot of left-handed people. So say sugar's right-handed. Mm-hmm. Your body, when you're eating stuff, is looking for right-handed sugars.
That's what our enzymes know how to break down. Okay. The binding sites to those enzymes are designed for the exact shape of your right hand.
And so whenever a left-handed, not quite sugar, but still tastes sweet.
Oh, it's still probably a sugar.
Okay. A sugar, but not like...
regular old sugar.
Yeah. Whenever a left-handed one goes through our body, enzymes are just like... like, they're not recognizing it at all. It's just going right past. They're not
it can't fit in. It's like trying to put your left hand in a right-handed glove. It wasn't made for that hand. It doesn't know how to do its job with that hand.
Yeah. So it just like doesn't even recognize, I'm supposed to do something with this. It just like, move along.
Passes through your body undigested.
Wow.
Crazy, right?
Yeah, that's really weird.
And that's it. That's all you need to know about artificial sweeteners in terms of how they work. They still taste sweet to us, but because our bodies are designed to break down the left hand instead of the right hand, or vice versa, those that our body doesn't know how to break down, they come in, they taste sweet, and then they pass through without being broken down.
That's interesting too, because then I don't think about this very much, but there's such a huge difference in taste and then what's happening once it hits your stomach and intestines and all that stuff. So it's like if you can achieve a taste up here while achieving something else down in the digestion section, like letting it pass through, for instance, that's kind of crazy because to our conscious mind, when we're thinking about what we want to eat, we're only thinking about taste much of the time.
Right. Well, and I don't like the taste of low-calorie sweeteners, and that's a real thing because they're not designed exactly the same way. So although they give us the illusion of sweetness or the sensation of sweetness, they aren't interacting with what you're experiencing exactly the same.
Right.
That's why I think some people just don't like that.
Yeah.
But just because they pass through your body undigested and they're 0 calories does not mean that they're perfect.
Right.
So one mixture of alternative sweeteners that they developed showed that they produced tumors in animals. So the FDA rejected it.
Okay.
As far as we know now, a lot of the things that are on the market that can sweeten our drinks and sweeten our candies or whatever, as far as we know, the FDA has done a good job of blocking them. But I think because they are not naturally occurring and we've altered them in some way to achieve a goal that probably isn't a common one, we don't know for sure what the effects are going to be.
Right. We haven't had like a long enough timeline necessarily of heavy use. It doesn't seem like I think the first Diet Coke hasn't even been around but like 50 years or 40 years or something like that.
I don't even know.
But like thinking about that being one of the first, like everybody has access to it kind of products. It's like, how could we really know what the long-term...
Right.
Man, that's interesting.
Yeah. So that's it. That's artificial sweeteners.
Dang, that's a lot simpler than I thought it was going to be. Like it's obviously, I know we could probably get way more granular and complicated, but at the like layman level, as it pertains to me and everybody else. I'm amazed at how simple that is.
I actually don't think that we simplified it very much at all. I think the thing that we would get into that would be more complicated is some of the biology parts. How could it cause tumors and negative impacts and all of that? I don't know a lot of that. But what you just said is the same way I would explain pretty much to an organic chemistry class.
Wow.
Then I would make them learn the designations of which one's left-handed and which one's right-handed and all of that. But that's not going to be as beneficial to understanding the aspects of these artificial sweeteners unless you're planning on going into a job and making them. So
Right.
you actually have a really thorough understanding of this topic. We didn't simplify it down significantly.
Dang, that's great.
I try not to, actually, usually for this show. I do want to say, before we move into the next portion of the show, that sometimes some of those enantiomers, sometimes the different handed sugar is found in nature, the one that our body doesn't break down, but it's pretty rare. Most of the time those have been synthetically formulated, but you can synthetically formulate things that are safe too. So don't let that worry you too much. Well, and I should qualify, sometimes you can find these opposite handed sweeteners in nature, but it's pretty rare. So most of them that we interact with are artificial, and they allow the sweetness with no calories. They pass through our bodies without being digested and contributing to our calorie intake, but they do have other effects that we're just not aware of right now that I'm sure will come to light over time.
Yeah.
So that's artificial sweeteners.
Wow. Man, that's crazy.
Yeah. Do you want to say it back to me?
Yes. Okay, so
You kind of have done already, but this is just a nice
wrap it up in a bow kind of deal.
wrap it up in a bow.
Yes, I can do that. So, like we talked about in a previous episode about that medication that had a very famous and very extreme different handedness of a molecule, which ended up causing deaths and deformities and a lot of not good stuff. Just like that, a lot of things have left-handed to right-handed versions of it. In this case, sugars and sweeteners. And so the handedness can look the same in a like just kind of two-dimensional kind of way where it looks like it's the same shape, but would have maybe a different way of interacting,
Right.
and maybe a slightly different like arrangement of some of the molecules or whatever, but would look the same way. And so
Would look the same way to the untrained eye.
right. And so, but it's different enough that there's still a sweet taste in the case of sugars and other sweeteners. There's still a sweet taste. But when the sweetener, when the molecule gets down into our bodies and our body's trying to digest it, the sugars that our body is used to digesting look one way, like the right hand, and artificial ones look on purpose the other way, the left-handed way.
Right.
And so our bodies do not recognize them.
Right.
And so they pass right on through
Yeah.
in disguise, basically.
Yeah. That's it.
Is that it?
Isn't that amazing that people are able to figure that out?
It really is. And I kind of wish there was like, that we could figure that kind of stuff out and it'd be like no potential consequences, no potential side effects. Like, it'd be kind of cool if we could start figuring that stuff out and learning more about our world over time.
Right.
Making those kind of things, and then it just solve problems. It's like,
Right.
sugar has the problems it solves, it has high calories, blah, blah, blah. We found this little sneaky cheat code hack kind of thing. We changed this substance up, still tastes sweet, does not have the effects that sugar has on your body. Boom.
Right.
Everybody wins. Wouldn't that be awesome if it was just that simple and there was no question marks?
Right. But just like with trans fats and margarine, we just don't know everything. I think that's a good reminder to humans. We just don't know everything. We don't know everything. And so we think that we've solved a problem, but you just have to be careful. And this is true for almost all of science. You find the most up-to-date information that gives the best answer that you have right now, but you have to be open to learning more later on.
And it kind of makes sense too, because then you think like, okay, if we did some sneaky science and figured something cool out, if this wasn't occurring like abundantly in nature, you kind of have to ask like, why? And if not, then is there some weird side effect of that.
Yeah.
You know what I mean? It's like if there was some perfect sugar that didn't cause any negative effects, but still tasted really sweet and tasted great that existed out there, then if we could make that, you'd think it would have to exist somewhere already.
Right.
You know what I mean?
Yeah.
It's just like that little bit of a weird understanding that I think a lot of us have, that like nature works in some way already.
Yeah.
And so messing with it can cause those unintended consequences that we don't always know soon enough.
You mess with the nature, you're going to get the horns. That's
what they say.
You mess with the bull. I definitely think that that's true. And it's just important to learn, when a new technology comes out or a new method of doing something comes out, my instinct is always to be careful and think through it rather than to jump right on it. So
right.
It reminds me of, I listened to an interesting podcast about the radium girls who worked with radium to use radium on watches, which is radioactive. And it was glowing because it's radioactive. It's emitting energy constantly, but it can give you radium poisoning. And just, it seemed like the new, best, greatest technology, and it was actually really dangerous. So I think that, again, the important thing there is not to be afraid of chemistry, but to have a healthy respect and to make sure that we're taking appropriate precautions when we're working with something that's newly discovered or that we don't know a ton about.
Word.
On that note, Jim, got anything exciting that happened to you this week? Anything that made you happy?
So this week, my wife was at a conference for work for a few days, and so she was out of town, and she got back actually this morning, which was awesome. So I was a single dad to our 2 dogs.
A single dad dog.
Yeah.
Wait, dog dad. I put that.
Sometimes people say like, "Oh, I was a bachelor this weekend because my wife was out of town," or whatever. I like saying I was a single dad for the weekend or whatever. Yeah, so she was gone and now she's back, and that made me happy.
I'm so glad.
Yeah.
That sounds not like a nice reunion, a fun reunion. I'm also glad she's back because I like her company and presence at church. And when I come over here to record podcasts, it's just more fun when she's around. So.
Someone said to me the other day, like they're kind of asking, someone who knows both of us was like, do you guys on the podcast ever say that y'all like know each other outside of the podcast and are like in the same friend group and all that stuff? And I was like, I think we kind of have like alluded to it clearly. Like it's obvious that you're friends with M and that we've talked about like the beach trip that you're supposed to go on and didn't go on. Stuff like that. But this person was like, yeah, you guys just seem to never really fully say it. So Melissa and I are friends and we were in the same friend group.
That's true. We're friends. We not only run this podcast together, but we also work on the same like leadership group at church and have a dinner club that meets every other week basically. And we're in a lot of things together. Yeah.
So it's not a lot of times when I talk about something like M being out of town or something that's been happening in my week or whatever, a lot of times Melissa knows about it or knows the people or whatever.
Or it has also impacted me.
Yeah, exactly. So anyway,
that's a good thing to know. I'm glad that you said that.
Yeah, it was kind of funny. I was like, oh yeah, it's one of those things that if you don't think about it, you just might not say outright or might not make it very clear, which could be confusing. So yeah, that was my week. What about you? What made you happy this past week?
Well, mine's kind of a small thing, but I have been watching my friend's baby Willow while my friend is working just a few hours a week. And Willow is, I think, about 1.5 years old. And so she is just really cute and funny. The other day, I was watching her and we were swinging outside on one of those safe kid swings, I would push her way up high and then let her go and she would just giggle and, those little kid laughs. And I just think being with kids helps you remember that all the things you're stressed about, all the things you're worried about, they matter, they're important, but there's more. Yeah,
there's some simplicity there that we lose.
Right.
Like just the thrill of being swung on a swing. Like that's some joy right there.
Yeah. And sometimes I would push her. I wouldn't hold her up and let go. I would push and then I would jump and strike a pose. And she thought that was hysterical. And I was not even doing anything funny. I was just jumping or whatever. So just being around a baby laugh was really nice.
Yeah.
And getting to interact with someone who's just starting to be able to experience the world and communicate it. It was just a very good part of my week.
Dang, that's awesome. Mm-hmm. Very cool.
Yeah.
I totally get that.
Okay, well, I've got 2 things for us to wrap up. One, another thing that's making me happy. We've seen some new countries show up in our listeners.
Nice. Awesome.
So I'd like to say welcome. Welcome to Denmark. Denmark, I was so excited when I saw you because I came to visit you this year and I loved you. I loved Denmark. It was beautiful. I really enjoyed it. I went with my mom. It was great. So welcome, Denmark. Also, Portugal. You finished off that part of Europe. So that was exciting.
That's right. It was just like it's an area that we didn't have. Yeah, thank you, Portugal.
Yeah, thanks, Portugal. Welcome. And very exciting, El Salvador.
Yes.
One of my roommates, former roommates, was El Salvadorian.
Yeah.
So
also very exciting is that unrelated, like I didn't realize that whenever I selected this, but I have been drinking this whole podcast a coffee that is from El Salvador that I roasted myself.
Wow.
Yeah. Cero Verde Taro, something like that.
Well, thanks, El Salvador, for making good coffee.
Oh, yeah. And for listening.
And I'd like to wrap up with my references. So this week, I used a combination of prior knowledge and the Organic Chemistry 11th edition textbook by Solomons.
Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. And if you enjoy this podcast, you can subscribe on your favorite podcast app. If you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong and A. Collini, who reviewed this episode.